Go ahead. Somebody else have something to say before we answer this question? Breathes oxygen. Interesting. So if something doesn't breathe oxygen, doesn't breathe, is it alive? Bacteria does exchange gases. Some don't use oxygen though. Yeah.
Wouldn't they have to have some form of organs?
Organs. So life has to have organs. Does that mean do bacteria have organs? Yeah.
Yes.
Say what? Maintains homeostasis. That's a good one, isn't it? Yeah. Well, here's the trick. You're all right and you're all wrong. You need a little bit of everything to answer the question. It is mean, but I can't eat the cupcakes, cookies either. I'm diabetic. So if they're going to bring in cupcakes, cookies, and tell me, you got cupcakes and cookies in the dining hall and I can't eat them, I'm going to tell you too. We suffer together. All right, so let's move on. So life. We know life started. Yeah. Oh, it's not on the screen. Yeah, sorry. All right. So life started, as we said earlier, life started around 4 billion years ago. There's a much more accurate timeline present, but I don't have it. My thing ran out of juice and I didn't plug it in. Give me a second. All right, you know what? We'll just grade notebooks, start grading them tomorrow. We'll talk later today. We'll grade notebooks tomorrow. I'll start tomorrow. So it started about 4 billion years ago. And the question is, how did we get from this soup is hot, bubbling, there's a lot of energy, high energy, solution, soup. How do we go from that to the first life? And what did that first life look like? Yeah.
Well, how we got from that to the first life? Wouldn't it be growth and evolution?
Well, how do you grow? That's true. Both are true. Everything you're saying is not wrong. But the question is, what do you need to do if you're going to have life? What do you need to do in order to have life come from this non-living? What's the difference between living and non-living? And one of the things that someone said that was very telling, it's kind of a broad concept, but you have to have something called homeostasis. You have to maintain order, maintaining status quo. There is a reality to the universe that's not very pleasant to think about, but the universe as a whole is moving toward higher entropy. You know this as chaos. The universe is moving towards chaos. That is an observation that is undeniable. Everything in the universe moves towards chaos. Every reaction moves towards increased entropy. Yeah, that means the randomness.
Yeah, do you mind because I've always had this question about entropy. How does one measure it?
That's a good question, but I'll have to get back to you on that. But we can talk during, it's more complicated than I'd like to get to right now, but it's a good question. Yeah.
If we started from chaos and we're moving towards chaos, was there ever a time where everything was just like calm?
Yeah. Now. You. You're it. Your life is a result of that. Life takes chaos and trades. It trades chaos and energy, and it creates organization. So life is going against what the rest of the universe, how the rest of the universe is moving. So this soup is going high energy, going towards chaos. How do we, what's the first step to be able to maintain homeostasis? To find peace, as you say. To find order, really, is what we're talking about, order. Your body's constantly moving. It's working very hard to maintain this because its natural state, the natural state of the universe is complete chaos. What is it that in some old texts, in some texts of some Bibles says, they say ashes to ashes and dust to dust? Or dust to dust and ashes to ashes? I don't remember which one.
Like, we all came from dust and we shall all return.
Yeah, we came from dust and to dust we shall return, or something like that. That's actually very true. All things came from dust. Life, I say we, I mean life. The plants outside, the bacteria, all life does is take the dust, the chaos, and create order. That's it. So how do you do that? How do you create homeostasis? How do you create order from this soup? So you got this soup of a bunch of different little things. And how do you take this and put order to it? What do you need to do?
This is going to be very broad. Organization.
Yeah, organization, but you can't. All right, so let me ask you a different way. You have a room. Have you ever been to your sister's room? Sorry, ladies, but this is my experience with my sister. Have you ever been to your sister's room? Those of you that have boys, or that have girls, that have sisters. Even if you yourself are not this way, ladies. If you are, I say sisters, boys are the same. It's just I think what happens with boys. I know in my experience, there were 4 of us, 4 boys and 1 girl in my family, and all the boys I don't know if we just didn't care enough to change our clothes every day multiple times, or we just didn't. I don't remember if we even bathed every day. I can't remember. But, I mean, boys can be a little grody. That's the truth. But my sister's room, I'm telling you, was complete and utter chaos. All the clothes were on the floor. It was literally knee deep in clothes. She used to put a sign on the door that said, "Do not enter. This means you," and she and us. Of course, what did we do? We went in because of the sign. So don't ever tell me no, because I'll just say, "Oh, okay." I'll be right there. So, anyways, my mother would go insane and tell her to clean the room. What did she have to do to organize the room? Organize it. All right, pick it up. She did. She spent hours. What do you have to do? She put it into closets. What she did, she shoved it all into a closet. First of all, I just want to say one thing. That's a really good example. And it really is kind of crazy that you said that, because that's exactly what she did. She literally put all the clothes in, just threw them all in the closet so she can go out with her friends. And my mom opened the closet and all the clothes fell on her. On her. She was not a happy camper. So, but interestingly, putting all the clothes in a closet, lift your head up and participate in the discussion. Hello, if you're sick, go to the office, sign in, please. Somebody tap her on her shoulder and let her know she needs to lift her head up. Take notes. Up, head up. Take notes. What do you say? Bathroom, go. Sign out. So, putting all those clothes in the closet was creating order. It was going to allow her to maintain homeostasis. She had to put everything in the closet. Of course, that wasn't my mother's idea of cleaning or organizing. What's a better way of organizing? Who has a better way of organizing? Yeah. A specific set of okay, and where would you and put them in the closet again?
Maybe
Wash them, fold them, then what? What?
them in a drawer, hang them up.
So put them in different. In where? Put them away where?
When they're supposed to take it out.
Where's that?
In the drawer?
In different drawers. That's what I was getting to. And look, think about this, guys. I'm just not telling you a story. I'm trying to get you to imagine what's going on here. This is not me wasting time. It's me trying to get to the essential pieces and parts of what life is. Hear me. You're taking those clothes, washing them, drying them, doing all kinds of actions with them, folding them, and putting them in drawers rather than all in one closet.
That's where they came from.
Well, they came from the store, but that's another story. So you put them in drawers. What is the difference between shoving them all into one closet versus putting them all away in different drawers? Compartmentalization. Correct?
Yeah.
That's it. The word is compart. Compartmentalization. Notice I spelled that correctly. And look how long. Now watch. I'm going to misspell the. I'm going to put T-E-H. I don't know why. I don't know if I'm slightly dyslexic. I have no idea, but I do it all the time. It really annoys me that I do it. I do it, and then I'm like, why did I do it again? The reason that's easy for me to spell is it's spelled the way it sounds. In Spanish, we spell the way it sounds. In English, you don't, because it comes from so many different languages. So it's actually very difficult to remember how to spell words in English. So anyways, compartmentalization is the key. Taking and creating. What is a compartment?
A storage unit.
It is storage, but when we talk about compartments, that's what this is. It's the compartmentalization is the creation of compartments. All right. So the question, I guess, goes back again. We have this soup. How do we create order from disorder? So you got this giant soup full of a bunch of different things, and you want order, and there's just this chaos of moving particles. How do we create order? We have to create what? What do we call a compartment? Yes, in the case of our example, they were drawers. But in the case of life, what is the compartment called? The cell. The cell is the compartment. It allows you to organize material. Allows you to stop the chaos. To fight against the ultimate disorder. You should be writing this down and drawing it, not staring off into space or rubbing your eyes. I'm just saying, it's going to be tough for you to do well. The cell. The cell is key. So compartmentalization is the creating of spaces. The creation. Why? This thing, I don't understand. Compartmentalization is the creation. Wow. The pencil just stops working. I don't know why. I don't see how. It says it's connected. Oh, it's 0%. That's why. Yeah, it's called my finger. All right. So the creation of space. Spaces, right? Drawers are spaces where you can put your socks in one, your underwear in the other, and your t-shirt and your shirts in the third, etc. Right? So a closet, which was my sister's first solution to her space, to her organization problem, is a space. It did work. It just wasn't as well organized. There was for her. It was just trying to get out of the house so she can go with her friends. But it didn't work. It doesn't work that way. It doesn't work as well as putting it in drawers. Does everybody agree? It's more organized to put things in drawers. So it turns out that that's how life is as well. The first life was likely a single cell. It's something called an archaea. Bacteria. It is something also known as a prokaryote.
Spell it with a K.
No, some people spell it with a C, but okay. Prokaryote. There's only one membrane in a prokaryote. One membrane. So that's it. And then inside does have DNA. This is a mistake that a lot of kids make, that there's no DNA in bacteria. They do have DNA. It's circular. Circular DNA. We call these plasmids. The circular chromosome. And then they also have tiny little circular pieces of DNA. I call them pieces, whatever. These are called plasmids. Sorry, I can't write neatly with my finger. Let me try again. So one circular DNA, and they have one big circular chromosome, and then a bunch of little plasmids. Yeah.
What exactly are plasmids?
Just small circular DNA instead of the big one. There's a big circular DNA, that's the bacteria's chromosome, and then you have tiny little ones that are just circular DNA. And then they have all the other stuff. So they just created the first cell was just this soup within a soup, right? This little room, and inside it, we call it the room. By the way, the room cell means a room. When you go to prison, you go into a what? A cell. That's a room. All right. So a cell is a room. And what you do is you create that created, of course, that someone said it earlier, they have to multiply. Why are you listening? Why do you have those in your ears? Why do you have those in your ears then? I don't understand. I don't get it, but whatever. So prokaryotes are a single room, single space, like my sister's closet, shoving things in. And that's fine. It worked. In fact, it worked really well. This one cell became prolific on planet Earth early on. And from North to South Pole, this single cell covered the planet. It was all liquid at the time, or a lot of liquid water. It was a soup. The thing is, it wasn't green. They didn't do photosynthesis the way we do it today. Lift your head up. They didn't have the ability to make chlorophyll, which is what makes plants green. Lift your head up. They did a different process. We still have some of these bacteria around today. We know they're purple in color. So the planet was likely, if you look down on it from space, it would look purple, because all the oceans would have been purple because this bacteria was purple. It did use the sun. It did photosynthesize. It just didn't do it the way our plants and other photosynthetic organisms do it today. They still photosynthesize using these purple colored pigments. Yeah.
So was the world like toxic? Was anything?
Well, was anything alive? Let's answer that question. Yeah. What was alive? The bacteria. So it wasn't toxic to the bacteria. Could we have lived back then? No, because there's something else that was missing. Oxygen. There was no free oxygen. There was nothing, there's no O2 gas. All the oxygen was trapped.
So was it
S-
like clean? Or
Huh?
was it just like
No, I don't know what you mean by clean. It was great for the photosynthesizing bacteria, that for the purple bacteria. It was great. They were happy. But then came along another bacteria, and it was able to take a part of another part of.
So this bacteria just showed up.
Well, in order to understand evolution, you have to understand DNA, and we haven't gotten there yet. So no, they didn't just show up. What they did is they evolved. So the DNA from this bacteria, there was one of its children had a mutation to the chromosome that produced a protein that allowed it to take advantage of a different part of the light spectrum, which made it look green. We call these today cyanobacteria. Yeah,
what does like the G beside O2 stand for again?
gas. Sorry about the messy writing, but I'm going to have to let it go. Cyanobacteria is around today. They are single-celled organisms that do photosynthesis. They are green. They did photosynthesis better. There was a competition. Do you see? Here in the plants that you're growing, you see there's competition. The little ones are competing against the big ones. Only the fittest will survive. So here there was a competition between the purple and the green. The green did it better. So the green took over the planet. There's still some purple bacteria left in different places. I'll show you if you like. Yeah.
What dictates mutation?
It's a really good question. We'll get into it, but to be clear, I'll outline it for you. Number one, mutations happen all the time. It's a natural course of doing DNA replication, copying DNA. Secondly, you can increase mutation by exposure to UV light, certain chemicals. They can increase mutation rates. And certain places in the DNA are more apt to mutate than others. So all those things influence mutations. So cyanobacteria outcompeted, and these guys right here changed the planet Earth. They freed up the oxygen, which allowed all the rest of us to be here. Not just them, but the plants that came after them. And obviously, the least of it is that the Earth went from purple to green. Green and blue now, because the blue is another story, but the atmosphere changed. These little tiny singles, remember what I told you about small things making a difference when there's a lot of them? These microscopic single-celled organisms changed the planet for the better, as far as we're concerned. Yeah. Yes, question, answer?
So in theory, all life on Earth evolved from cyanobacteria and the purple one?
Correct. These were the first. And that is the theory, and I'll show you the evidence tomorrow. Yeah.
So does like science and religion contradict each other?
It depends on what you believe each to mean.